Before we can start graphing two variable inequalities, we need to make sure that we understand what it means for an ordered pair to be a solution to an inequality. We can do this graphically and algebraically. On our practice graphing linear inequalities worksheet, we're going to look at doing this both graphically and algebraically. First, we want to identify our ordered pair, 3, -4. On our graph, if we look for the point 3, -4, that's right here, and because that's in the shaded region of our graph, that means that that ordered pair is a solution to that inequality. It's important to remember that our inequality, our graph, has two kinds of boundary lines. A dotted line is used when our inequality is strictly greater than or less than, and a solid boundary line would be used if we had greater than or equal to or less than or equal to. So if we consider the ordered pair 4, 1, the ordered pair 4, 1 is right on my boundary line. But because that boundary line is dotted, I'm not allowed to equal points on that line. My point is on the boundary line, and the boundary line is dotted. That means that this ordered pair is not a solution to the inequality. Had my boundary line been solid, or my inequality included the or equal to option, then this ordered pair would have been included in my solution set, but it is not. We can verify these 2 points algebraically if we consider what our original inequality was. 3x minus 4y is greater than 8. And if I'm checking to see if the ordered pair 3, -4 is a solution to this inequality, I simply plug in my x value and my y value, and then I'm going to put a question mark over my inequality symbol because I'm checking to see if it's true that that will be greater than 8. So 3 times 3 is 9, -4 times -4 is 16, and 9 and 16 is 25. 25. And 25 really is greater than 8. So that tells me, yes, this ordered pair is a solution to that inequality. Now we knew that graphically because we could see that that ordered pair, that point, is in the shaded region of my inequality. But let's check B. If I'm going to check to see if the ordered pair 4, 1 is a solution to the inequality, again, I'm going to plug in the x and the y values into the inequality that was given to me. So I'll plug in x for 4 for x, and 1 for y, and I'm checking to see if that's really greater than 8. 3 times 4 is 12, 4 times 1 is 4, and 12 minus 4 is 8. But 8 is not greater than 8. 8 would be greater than or equal to, which is why we know that the ordered pair 4, 1 is not not a solution to my inequality. And again, that goes back to that point is right on my boundary line, and because my inequality didn't include or equal to, any point on this boundary line is not a solution to this inequality.